Hi, this is video 4 of week 5. We're now looking at the multiple units balance when we add more units including bypass and recycle. What we have seen previously is just a simple process unit where there are only input and output. Conventionally, the chemical processes are more complicated, meaning there are usually more than one unit, and there are also recycle and bypass streams. For example, if the process unit is a reactor, most of the time the reaction hardly proceeds to completion. So there will always be the unreacted species, and the recycle of this material will enhance the process efficiency as well as minimize waste. Hence, the recycle is just the downstream that returns the material back to the reactor. Normally, the outlet or product stream is fed to a separating unit to separate reactant from product before it is recycled back. In this case, the composition of the recycle will be different from the product and the reactor outlet. But if a separator is not used, then the composition of the recycle will be the same with the outlet from the process. On the other hand, feed might get diverted around the process to mix directly with the downstream to achieve certain properties, for example, viscosity or density. Normally, separating unit will not be used here for bypass, so its composition will always be the same with the inlet or the feed. Let's look at the example of the multiple units. This example is the process of extracting oil from soybean using hexane. The main unit is the extractor where soybean is mixed with hexane. The mixture of soybean or solid oil and hexane will then fed to the filter where solid part is removed. The liquid phase is hexane and oil will be refined in the evaporator where hexane and oil are completely separated. The solid phase from the filter will also carry some liquid with it. And in this liquid, which is the mixture of hexane and oil, it will have the same composition with the liquid phase leaving the filter since they are exact same liquid phase before separating at the filter. Hexane vapor from evaporator is then condensed and recycled back to the extractor. Oil may or may not be completely extracted from the solid. There might be some oil left in soybean meal or in the filter cake here. In this case, oil in filter cake will be the unextracted oil and oil in the liquid that solid phase carry with it. Now, let's look at the problem statement. For the ease of calculation, we will assume that oil in soybean meal are completely extracted and are all dissolved in hexane. What we have here is beans containing 13% by weight of oil and 87% of solid. And the ratio of feed to bean is 3 kg of hexane per 1 kg of beans. After the extractor effluent passed to a filter, the filter cake contains 75% of bean solid and the balance is oil and hexane. And the ratio of oil and hexane in filter cake is the same with the effluent from the extractor. So we need to first perform degrees of freedom analysis to see where should we start our calculation. And then we need to calculate the yield of soybean oil product, the required fresh hexane feed, and the recycle to the fresh feed ratio of hexane. First of all, we need to set up our basis. Since there is no basis given in the problem statement yet, so we will set up our basis as 100 kg per hour of beans fed. And since we don't want to deal with the flow rate, so we will also set up the basis for 1 hour operation, this will take care of the flow rate. It will be just the amount in 1 hour operation. So from the basis, we know that M6 equal to 100 kilogram, and from the ratio of feed to hexane, we also determine M2 equal to 300 kilogram. After setting up the basis, we can now identify our known and unknown variables, because we're going to use unknown variable approach in this case. So for M1, M2, and M5 here, there is only one species, so you have only one variable here. For M6, since we already set up the basis of 100 kilograms, so we know how much oil in here, which is 13 kilograms, and the rest would be solid. And M2 is also 300 kilograms. M3, or the effluent from extractor, contain 3 species, as well as M7, which is the filter cake or the solid. And M4 here contain only 2 components or 2 species, which is only oil and hexane. And after that, M8 is oil, which is product. And M5, it's only hexane. Let's begin with the overall balance, which all the units here is combined. So the streams involved are 1, 6, 7, and 8. And the number of unknown variables are 5. Since we have 3 from 7, if you recall, the number of variables here equal to number of species. So in stream 7, we have 3 species, so we have 3 unknown or variables. And we have one each from 1 and 8. All the variables from 6 are already known. For number of equations and specification, we have 4. 3 are from material balance equation because we have 3 species. And the other one is specification from solid content in stream 7. So NDF for overall is 1. For the mixing point, streams involved are 1, 2, and 5. Since we already know what is M2, so the variables, the unknown here, are 2. 1 from each M1 and M5. But we only have one material balance equations because we only have one species here. So NDF for mixing point is also 1. For extractor, streams involved are 2, 3, and 6. But there are only 3 unknown from stream 6, and we have 3 material balance equations to solve for those 3 unknown. So NDF for extractor equal to 0 here. For filter, stream involved are 3, 4, and 7, but we have 8 unknown. 3 from 3 and 7 because those 2 has 3 species, and 2 from 4 because stream 4 has only 2 species. And we only have 5 equations and specification here. 3 from material balance, another one from oil and hexane ratio for stream 3 and 7. The 5th equation and specification is solid content in stream 7. So NDF for filter is 3. Lastly, for evaporator, streams involved are 4, 5, and 8. Number of unknown variables is 4, 2 from 4, and 1 each from 5 and 8. But we only have 2 material balance equations because we only have 2 species involved in this unit. So NDF for evaporator is 2. Now we know where to start our calculation, which is extractor. So we write 3 material balance equations to solve for the 3 unknown. First, total balance. M3 equal to M2 plus M7, which is 400 kilograms. And for oil balance, we can calculate the amount of oil in stream 3, which is 13 kilogram. And for the solid balance, we can calculate the amount of solid in stream 3, which is 87 kilogram. And after all that, we can also calculate the amount of hexane in stream 3, which is 300 kilogram. Now we can move on to filter, because right now we can identify 3 of the unknown. So for the filter now, the number of degrees of freedom should be equal to 0, and we can proceed with material balance equations. First of all, the solid content in stream 7, we know that it is 75%. So the mass fraction of solid in stream 7, or XA7 here, if we express in terms of equation, we can write down XA7 equal to MA7 over M7. MA7 is the amount of solid in stream 7, and M7 is the total amount of the solid or filter cake phase. And we want to find out what is M7. We already obtained MA7 from the above equation, and XS7 is given to us. So M7 is equal to 116 kilogram. Next, we can write down mass balance and calculate M4, which is 284 kilogram. From hexane and oil ratio, we know that the oil over hexane in stream 3 equal to stream 7. The amount of hexane in stream 7 now can be expressed in terms of the total mass of 7, and this is the mass of solid, and this is the amount of oil. So after we substitute MH7 into the above expression, the only unknown left there would be the mass of oil in stream 7. From this expression, we can calculate the amount of oil in stream 7, which is 1.2 kilogram. And after that, we put this back in here so we can calculate the mass of hexane in stream 7, which is 27.8 kilogram. From oil balance, we can calculate the amount of oil in stream 4, which is 11.8 kilogram. Consequently, we can determine the amount of hexane in stream 4 as well, which is equal to 272.2 kilogram. At the evaporator, for oil balance, which is M8, it's equal to the amount of oil in stream 4, which is 11.8 kilogram, and M5, which is the mass or the amount of hexane that got recycled, is the difference between M4 and M8, which is 272.2 kilogram. Lastly, at the mixing point, now we can calculate the amount of fresh feed hexane, which is 27.8 kilogram. And now, since our system is fully determined, meaning all the unknown has been solved and identified, we can calculate the yield and the ratio as follows. First, the yield of oil produced over the amount of bean fed is about 12%. And the ratio of fresh hexane fed over bean fed is about 28%. And the last but not the least is the amount of hexane recycled per hexane fed, which is 10. And this is good for our process because we can recycle the solvent 10 times of what we have to feed freshly. So if you can do this with all the process, it would be quite efficient.